Okay, Assalamualaikum and good day everyone. My name is Natasha Liana and today I would like to present about PN Photodiode. So let's start. Okay, first of all, what is photodiode? Photodiode is a semiconductor device that generates electrical current from optical light, or we call it as photon. And here is the symbol for the photodiode that normally all of us use. There are a few different types of photodiode, but for this presentation, I would like to talk about PN junction photodiode. So what is PN junction photodiode? This is the most basic photodiode where the PN junction is a P-type semiconductor is fused to the N-type semiconductor and creating a potential barrier voltage across the junction diode. And normally for this type of photodiode, it's connected in reverse bias mode where the P-type semiconductor is connected to the negative terminal and the N-type semiconductor is connected to the positive terminal of the battery. Okay, as mentioned earlier, PN photodiode is connected in reverse bias mode. So this mode causing the majority carrier, which is electrons and holes, to move away from the junction. As a result, depletion region here become wider and causing the P and N region getting smaller. This depletion region acts as barrier to stop the majority carriers to move across the junction. However, there are still a few carriers that are able to move across the junction to the opposite side and become minority carrier. While the electrical charge, which is the positive and negative ions in the depletion region, they will exert electrical field and started to produce drift current. So now let's see what is happening when photon is absorbed. First, light is emitted into anywhere of the absorption region. As you can see here, the absorption region consists of depletion region and also diffusion region. So current will generated when photon is absorbed in the depletion region. So this phenomena will create electron hole pair, or we call it as photoelectric effect. The existed electric field in the depletion region here created drift current to help electron hole pair to move away from the junction. So now I will explain what will happen at diffusion region. As you can see from this graph, diffusion region is only a small region ever exists in the overall absorption region at the N-type semiconductor, which is only this part. In this N-type semiconductor, we know that electrons are the majority carriers while holes become the minority carriers. But since the connection are in reverse bias, holes started to move toward the P side here by diffusion current due to the diffusion effect occur in the diffusion region. Then these holes will go through the depletion region and moving with the help of drift current existed. In comparison, drift current is much larger than diffusion current. So this causing carrier to tend to move slower at the diffusion region. However, this diffusion current produced from the diffusion effect is not essential since it's slowing down the movement of holes. And this is the rise of the problem for the device. So we need to replace diffusion current with drift current. So how are we going to do that? We know that the depletion region width depends on the carrier concentration of P and N semiconductor. So the standard depletion region width for this device is 1 to 3 micron only. So to remove the diffusion region, we should expand the depletion region by using PN photodiode. But for this presentation, I will not go further and explain about photodiode. Okay, move on to the last part, how we can relate this PN photodiode with fiber optic communication. So basically, we know that fiber optic communication is using light signal to transfer data from one end to the another. While the main idea of PN photodiode is to convert the light signal back into the electrical signal. So we call this as optoelectronic device. LED and laser are normally used as the light source in the fiber optic. So the PN photodiode will act as the optical receiver of the light before convert the signal into electrical output. The reason why we use reverse bias PN photodiode is because speed is the main concept of fiber optic communication, as the responsive time is improved. And lastly, the reason why depletion region width should be around 1 to 3 micron only is because it is optimized for the efficient detection of light at certain wavelength, depends on the semiconductor material. Okay, that's all from me. Thank you for listening.